Now we'll see a program to find the sum of n natural numbers, or it can also be asked as write a program to find sum of the series 1 plus 2 plus 3 so on up to n terms. Now the same program can be done using all types of looping concept. We'll take the same example and do the program using various looping constructs. So first, now in this I have made use of the while looping construct. So now since while loop you are using, we need to make use of a variable to keep track of how many number of times the loop has to be repeated, and then I need to accept the nth natural number, that is the limit I have to accept from the user. So I need a variable to store that limit, and then I have to compute the sum of is n natural numbers. So I have made use of another variable to store the sum. So now in this int count equal to 1, I have initialized the count to 1. That keeps track of how many number of times I'll have to repeat, or how many number of times I'll have to continue the execution in loop. So because the series starts from 1, 1 plus 2 plus 3 so on up to nth term, that's why I have started the count at 1. So from 1 till the count reaches n. So next I have made use of variable n to accept the nth natural number from the user. Then sum is used to compute the sum of the series, and I have initialized it to 0. So next, now scanf statement there, it will accept the input from the user. Next, while loop. So while count is less than or equal to n. So first initially count is 1. Now I'll take the example of whatever I have shown here, the output. So enter the nth natural number. So user inputs the number as 3. So now this series will be 1 plus 2 plus 3. So these three terms I'll have to add, and that becomes the sum of the series. So now count is less than or equal to n. Now n value is 3, so now the control will come here. While count is 1, 1 is less than or equal to 3. That is true. So sum equal to sum plus count. So in the first iteration, sum is already initialized to 0, so 0 plus count. Count is 1. So now 0 plus 1, so what will be stored in sum? That is 1 will be stored in sum. Now I'll increment the count. So count is incremented from 1 to 2. Now again the control will go back to the while test condition. So now count value is 2. So 2 is less than or equal to 3. That is true. So again the control will come inside the loop, and now the body of the loop is executed. Now again sum plus count. Now the previous value of sum was 1. 1 plus, now the count is 2. So 1 plus 2. So 3 will be stored in sum. Now again count is incremented. So count is incremented from 2 to 3. Now count becomes 3. So 3 is less than or equal to 3. The condition is checked. Now again it is true. So control will come inside the loop, and now again the sum equal to sum plus count is executed. This time the sum value, the previous value was 3. So 3 plus the count is now incremented to 3. So 3 plus 3, that is 6, will be stored in sum. Now again count is incremented. Count becomes now 3 plus 1, 4. Now 4 is less than or equal to 4. This condition is not true. So control will come out of the loop, and the next sequential execution takes place. That is the next statement given there is a printf statement. So sum of the series up to percentage d terms is percentage d. That is, I want to display the sum of the series up to nth term. So nth term is the nth term value I have stored in variable n, which is of integer type. That's why I given here percentage d terms is the result is stored in sum. Again sum is again integer type, so I have mentioned here it as percentage d. So the output will be the sum of the series up to 3 terms is 6. So this is the sum of natural numbers using while loop. Now the same program we can also write it using do while loop. As I previously explained in the previous slides, do while loop is used when we are sure that the body of the loop must be executed at least once, or will be executed at least once, irrespective of the conditions. So here the program is to find the sum of the series which starts from 1 plus 2 plus 3 so on up to n terms. That's why the minimum limit what the user can give is 1. So if it is 1, then at least once the body of the loop has to be executed. That's why I can also make use of the do while loop. All initializing variables, everything is same to the previous like the previous program. Now here I'll just explain the do while part. So I given do. So since do while loop, the condition is not checked at the beginning, condition is checked at the end. So the control will directly go inside the loop and sum equal to sum plus count. So sum again it is initialized to 0. So 0 plus count. Now count is initialized to 1. So I have given input as 3. So now 0 plus 1. So that is the total is 1, that will be stored in the sum. Next count is incremented by 1. Count is incremented from 1 to 2 and then the while count is less than or equal to n. Now the condition is checked. If the condition is true, then again the control will go back inside the loop. Now count value is 2. 2 is less than or equal to n. N value is 3. So 2 is less than or equal to 3 is true. So the control will go back to the loop. Now again body of the loop is executed, that is sum equal to sum plus count. Now the value of sum is 1 plus the value of count is 2. So 1 plus 2, that is 3, is the new sum now. So that will be stored in sum. Count is incremented by 1, count becomes 3. Now again the while condition is checked. So 3 is less than or equal to 3, that is true. So again control will come back to inside the loop. Now sum plus count. Now the previous value of sum was 3. So 3 plus the count value is now 3. So 3 plus 3, that is 6. So the new sum value will be 6. Then the count is incremented by 1. Count becomes 4. Now while count is less than or equal to n. Now 4 is less than or equal to 3. The condition is false, so it will not, the control will not go back into the loop. It will come outside the loop and the printf statement is executed. So the sum of the series up to 3 terms is 6. Now the sum of n natural numbers, the same program is implemented by using for loop. Now here instead of count I have made use of variable I here. So all other things, initialization, everything is same. Now we'll directly move to the for loop. Now the for loop, as I previously explained, there are 3 parts. First part is the initialization part, second is the condition part, third is the updation part. So now I made use of I to specify how many number of times the execution of the loop must takes place. So I equal to 1, that is the initialization part. I have already declared the variable I. So now here I am using the variable I as the initialization. So I equal to 1. I is initialized to 1. Now the control will come here, I is initialized to 1. Then immediately it will check the condition. I is less than or equal to n. N I have given input as 3. So 1 is less than or equal to 3. That is true. So control will go inside the loop. Now sum equal to sum plus I. That is sum equal to 0 plus 1. So the new sum value will be 1. So new sum value is stored here in sum. The new value is 1. Now after this the control will go to the again into the for loop and now it will move to the last part, that is the updation part. Now I plus plus. So post increment I have given. So I value will be incremented by 1. So I was 1. So it is incremented by 1. So I value becomes 2. Now again it will check the condition now. Now 2 is less than or equal to 3. That is true. So again the control will move back into the loop. Sum plus I. Previous value of sum what is stored is 1. 1 plus 2. So 3 will be stored in sum. Again now the control will go to the updation part, that is I plus plus. Now I was 2 will be incremented by 1 and I becomes 3. So now it will check the condition I is less than or equal to n. So I is 3. 3 is less than or equal to n is 3. So 3 is less than or equal to 3. Condition is true. So again it will come back inside the loop. Now sum equal to sum plus I. Previous value of sum was 3. So 3 plus I value is 3. So 3 plus 3, 6. So some new value of sum will be 6. Now again it will go to the updation part. I will be incremented by 1. I was 3. Now 3 plus 1, 4. I becomes 4. Now again it will check the condition. 4 is less than or equal to 4. Now this 4 is less than or equal to 3. Now the condition fails, so it will come out of the loop and execute the printf statement. Now we will look into the program to check whether the given number is prime or not. Now I have made use of integer here, integer variable I, n and flag. I is used to iterate through the loop, n is used to accept the number from the user, flag is used as an indicator to know whether to indicate whether the number is divisible by any other number other than the entered number and 1 itself. So for that indication purpose I use the variable flag. Now printf statement again to enter the number, then using scanf I'll store it in n. Now here after accepting the number, now I have to start dividing that particular number by 2 and until one number less than the entered number, or if you just divide it by half of the numbers also, we can find out whether it is prime or not. For example, for 7 you need not divide it, you need not continue division until 6. If you just check with 2 and 3, you can make out whether it is prime or not. So that's the logic what I have used over here. That's why for loop I is equal to 2, then I is less than or equal to n by 2, then I plus plus, that is the increment. So until the I reaches the value that is equal to n by 2, that is half of the given number. Now for example, you have taken here n as 7. So user has input the number n as 7. So now the control will come to the for loop. So initial value of I have given it as 2. So it will now check whether 2 is less than or equal to n by 2. Now n by 2 is 7 by 2, that is 3. So I is 2, 2 is less than or equal to 3, the condition is true, so the control will go inside the loop. Now I am checking whether it is divisible by 2 or not. So if n mod I is equal to 0. Now 7 mod 2, whether it is equal to 0. 7 mod 2 is not equal to 0, that is 7 is not completely divisible by 2. That is why this condition becomes false. So the control will not go inside the if part, it will again move back to the for loop. Now the updation takes place. I is incremented by 1. I was 2. I is incremented to 3. Now again it will check the condition 3, whether it is less than or equal to n by 2. N by 2 is also 3. So 3 is less than or equal to 3. The condition is true. So it will come inside the loop. Now if n mod I is equal to 0. So again 7 mod 3, whether it is equal to 0. It is not equal to 0 because 7 is not completely divisible by 3. So remainder you will not get it as 0. So that is why the condition is false. So again the control will move back to the for loop. Again updation. Now I is incremented by 1. So I was 3, I is incremented to 4. Now it will check the condition whether I is less than or equal to n by 2. Now I is 4, 4 is less than or equal to 3. Condition is false. So it will come out of the for loop. Now I have given the if part there. Now if flag is equal to 1. So flag becomes only 1, flag becomes 1 only if the number was divisible by any other number. So that condition was not true here. So flag value what I have initialized, that is 0. So flag value remains the same. So if flag is equal to 1, that condition is false. So the control will move to the else part and it will print percentage %d is a prime number. That is 7 is a prime number. Now if you take any other example of a non-prime number, that is, let us say if I take an example of 4, then n value is 4, then the control now will come to the for loop. I is initialized to 2, n by 2, that is 4 by 2, that is 2. So it will check the condition whether 2 is less than or equal to 2. So condition is true, 2 is less than or equal to 2 is true, so it will come inside the for loop. Now it will check if n mod I is equal to 0. Now I have given n as 4, so 4 mod 2, whether it is equal to 0. Yes, it is true, because 4 is completely divisible by 2 and the remainder we get is 0. That is why flag is equal to 1. So now once flag is equal to 1, that means 4 is divisible by another number other than 1 and 4. So that means it is not a prime number. That is why I have given the break, because once it is divisible by any other number, then I need not further check whether it is divisible by any other number. Once with one number, if it is divisible also, it is not a prime number. So I have given break. Once I give the break, counter will directly come out of the for loop. Now flag value is changed to 1. So if flag is equal to 1, condition is true. So it will display 4 is not a prime number. So execute this program with different inputs and check.